Understanding the nuances of mixing doughs and batters is essential for a successful, high-quality final product. For tender products, the mixing time is shorter, but for chewier products like yeast-leavened breads, a longer mixing time is needed. There are 3 phases of the mixing process: blending the ingredients, forming the dough, and developing the dough. Despite variations in the types of doughs and batters, ingredients and the qualities of these ingredients, 3 main processes occur and are common in the mixing process: air cell formation, hydration, and oxidation. Air cell formation produces the porous texture in the interior of the baked goods, that portion of the item known as the crumb. A necessary part of the leavening process, the air cells are encased in elastic walls made primarily of proteins from gluten or albumin. Air cell formation occurs from the natural air present in the ingredient particles. Additional air is introduced through certain liquids and egg foams, as well as the mixing process. Gases formed by leavening agents can cause further air cell formation. As soon as the mixing process begins, air cells begin forming. Hydration is the process of absorbing water. Starch does not dissolve in water, but it does attract and bind with water. The water forms a coating around each starch granule. During the baking process, heat causes the starch to finally absorb the water and gelatinize. This gelatinization contributes to the structure of baked goods. Proteins, on the other hand, bind with water and form gluten strands. Mixing develops these strands into webs, contributing further structure to the baked goods. Oxidation occurs when oxygen from the air reacts with proteins and other components of flour during mixing. When oxygen combines with gluten, it strengthens the strands. Developing gluten structure is one of the most important concepts to understand in the mixing process. Gluten is formed when 2 proteins in wheat flour, glutenin and gliadin, are mixed with water. These 2 proteins join together to form strands. The glutenin provides elasticity, and the gliadin provides extension and length. Different flours vary in gluten strength. Weaker flours such as cake and pastry flour are ideal for tender products like cakes, cookies, biscuits, and quick breads. Stronger flours like bread and high gluten flours are ideal for chewier products that require more structure, like baguettes, bagels, and pizza dough. Mixing time also affects gluten development. Tender products require a shorter mixing time for less gluten development. Chewier products and most yeast-leavened breads require a longer mixing time for greater gluten development. If too much mixing occurs, gluten strands can break, causing a sticky, stringy, and slack dough. If the strands are broken by too much stretching, the final product will lack the necessary structure. Most dough requires a resting period to give the tight and stretched gluten strands a chance to relax. Without this rest, the dough may be difficult to shape and work with, and the final product may be reduced in size.